Imagine this. You obtain a super spaceship that breaks the laws of physics. Its speed isn't the speed of light, not twice the speed of light, but an astonishing 1 light-year per second. That's over 31 million times the speed of light. At this point, you might think the universe is yours to roam, that going anywhere is an instant affair. But the truth isn't quite like that. Today, let's simulate this insane journey of 1 light-year per second and see just how big the universe really is. In the average person's understanding, the solar system is huge. But at this speed, you would pass through the inner Oort cloud in just a few seconds. The entire solar system is no longer a concept of space to you. It becomes just a flash in an instant. You don't need to wait bored in the vast, long interstellar void. In the single second you glance down at your watch, you've already traveled 1 full light year. When you look back, the sun has become just an ordinary star, not much different from the countless others around it. The Milky Way is a massive barred spiral galaxy containing 100 to 400 billion stars, with a diameter of about 100,000 light-years. For light itself, crossing the galaxy takes 100,000 years, a timescale that makes human civilization feel unbelievably small. But for you, it takes only just over 27 hours, a little more than a single day. You don't even need to pack much. Bring a few packs of instant noodles, fall asleep in your ship, wake up, and watch a few movies. When you look out the window again, the magnificent wall of the Milky Way has already shifted from in front of you to behind you. You'll see the bright, dazzling bulge at the galaxy's center, and you'll skim past countless star systems like our own solar system. At this stage, the universe still feels huge, but manageable. After all, you can tour an entire galaxy in a single day. Is the universe really just this much? So you set your sights on the next destination, our neighbor, the Andromeda Galaxy. It's 2.54 million light-years away. In astronomical terms, that's practically next door, but in terms of space, it's an abyss. Even with your super spaceship, it still takes about a month to get there. It feels like ancient sailors crossing the Atlantic. During that month, the view outside the window is almost frozen. Ahead of you, Andromeda is just a tiny point of light, growing a little bigger each day. Behind you, the Milky Way is also just a tiny point, shrinking a little each day. Around you is complete and silent darkness and endless emptiness. You start to feel a hint of boredom. You realize how vast the distances between stars truly are, and how unbelievably empty the distances between galaxies are. Still, a month is something you can endure. You arrive at Andromeda, take a moment to capture the memory, and then continue deeper into space. Now comes the main event. Your target is the edge of the universe. In astronomy, this usually refers to the boundary of the observable universe. Current observations show that the radius of the observable universe is about 46.5 billion light-years. You do some quick math in your head. Crossing the Milky Way took only a day, reaching Andromeda took only a month, so getting to the edge should take just a few years, right? The answer is 1474 years. Let that number sink in. Even if you can travel 1 light-year per second, even if you leave the speed of light far behind you, you still can't reach the edge of the universe within a single lifetime. This is a journey destined to have no true endpoint. When you set off, you're a spirited 20-year-old. After flying for 60 years, you're already an 80-year-old, frail and gray. By then, you've traveled less than 2 billion light-years, not even 4% of the universe's radius. Your descendants would need to live and grow aboard the ship for 50 generations, from the time of ancient empires all the way to the modern age, before the ship could finally touch the boundary of the observable universe. This is the scale of the cosmos. In the face of true vastness, even 1 light-year per second is still slow by comparison. Suppose your ship has cryogenic sleep pods, and you endure those long 1474 years. You look out the window, expecting to see a gigantic wall, or a boundary marked with some kind of final message, or a blank, empty void. But what do you see? Nothing. Or more accurately, you see exactly the same scene as when you first set out. This touches on one of the strangest principles of cosmology. The universe has no edge. The so-called 46.5 billion light-year radius of the observable universe is centered on Earth. It's simply the farthest distance light has been able to travel in 13.8 billion years. When you fly to that point, your own observable bubble moves with you. You'll discover that it's still filled with galaxies. You'll find that ahead of you, there's still another 46.5 billion light-years of view. You'll realize that Earth has become a distant past, while you remain at the center of your own perspective. It's like sailing on the ocean. The end you see at the horizon, when you steer your ship there, reveals only more endless water and a brand new horizon forming in front of you. What's even more astonishing is that the universe is expanding. During those 1474 years of your flight, the universe itself is also growing. Although traveling 1 light-year per second is far faster than the rate of cosmic expansion, you truly can catch up to distant galaxies. If you're trying to find the edge of space itself, that's something you may never reach. That's because the universe is very likely infinite, or finite, but without boundaries. If the universe is spherical, then after countless cycles of these long journeys, you might eventually return to your starting point and see the remains of the solar system, its sun long extinguished, reduced to a cold, dark stellar remnant. If the universe is flat and infinite, then you'll fly on forever, until the end of time, always moving forward, never seeing a wall. And if you truly travel at tens of millions of times the speed of light, your eyes would witness something both awe-inspiring and overwhelming. First, the wavelength of light ahead of you would be dramatically compressed. The visible light from stars in front of you would be intensely blue-shifted, transforming into high-energy radiation far beyond what humans could safely observe. Without advanced shielding, this radiation would become instantly destructive to any known spacecraft. As your speed approaches and surpasses light itself, every ray of light in your field of view would be pushed toward the exact direction you're traveling. You wouldn't see stars scattered across the sky anymore. Instead, you'd see complete and silent darkness in every direction. All the starlight would collapse into a single point straight ahead, an incredibly tiny, incredibly bright, and incredibly powerful point of light. And you would surge forward toward that blazing focus of the universe itself. This is the reality of traveling 1 light-year per second. We often imagine that if our engines were powerful enough, we could conquer the universe. But mathematics tells a different story. The universe is so vast that even at impossible speeds, it remains beyond the reach of any single lifetime. Faced with an observable cosmos nearly 93 billion light-years across, and a universe that may stretch endlessly in all directions, we are reminded not of our weakness, but of how extraordinary it is that we exist to witness something so vast at all. If you enjoyed exploring the cosmos with me today, don't forget to like, subscribe, and hit the bell so you never miss a voyage into the stars.